We are now going to solve applied problems involving linear inequalities in two variables. The real key here is making sure you understand the keywords as they appear. If something is at least as much as something else, then it has a minimum. It has to be at least that value, but it could be bigger. It also is an or equals because you could get away. If x is at least 4, then x is greater than or equal to 4. Likewise, at most implies a high point. And so if x is at most 3, then x would be less than or equal to 3. So let's look at a particular example. Suppose that Sammy likes to go to McDonald's for lunch. He's on a diet that requires that he consume no more than 150 grams of carbohydrates for lunch. Now when he goes to lunch, he likes to get the filet-o-fish sandwich and the french fries. Each filet-o-fish has 45 grams of carbohydrates, and each small order of french fries has 40 grams of carbohydrates. Write an inequality that describes the possible combinations of filet-o-fish sandwiches and french fries that Sammy can eat. Graph the inequality, and then give three ordered pairs of solutions. So we're going to start by recognizing x is the filet-fish sandwiches and y is the french fries. So we know that he has a maximum of 150. So that's the highest it can get. So we're going to write that as a less than or equal. We also know that for each fillet that he eats, he will have 45 grams of carbohydrates. So 45x plus 40y is less than or equal to 150. Here's our default inequality. That describes everything we need to know. However, we can, if we want, make it simpler. We can divide everything to make them easier to get to. So notice if we divide everything by 5, we'll get 9x plus 8y is less than or equal to 30. And this is going to be a little bit easier to graph for us. Well, let's just finish it. Let's solve for y. So let's subtract 9x. And that gives 8y is less than or equal to 9x plus 30. From here, we divide everything by 8. Reduce any fractions that we can. This comes 15 over 4. And so we have minus 9/8 x plus 15 over 4. Well, if we were to make each of these big tick marks 1, 15 over 4 is up 3 and a little bit. 3 3/4. Oops. So here's our dot. We then go down 9, so let's go down in quarters. 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's another point. And down 1, 2, 3, 4, 5, 6, 7, 8, 9 puts us here, and then over 8 puts us here. And we can draw our line through that. And notice it's a less than or equal. And notice that I'm only looking in quadrant 1 because we can't eat negative french fries and we can't eat negative sandwiches. So we're looking in this region right here. And so now it asks to pick 3 coordinates that work. So I'm going to pick 1 and 1. I can have 1 fillet and 1 french fry. That'll work. I can also have 3 fillet and 1 french fry. Or I can have 1 fillet and 3 french fry. or 1 and 2. And notice I can also sneak in 2 of each if I really want to. So these are all valid amounts that I can have. And I can also have along the zeros. I can have nothing, or I can have just the fillet. I can have 4 fillets, or I can have 4 French fries, or some combination of those purple dots. So that's using the inequality, what we've learned, with an applied story program.